All right, let's have a look at color images. Open up image J to get this floating menu here and go File, Open, that is open one of our images. 345 images or images for 345, whatever you've called it. Look down here. It might be a little bit different than mine, but look down and find Lena Color and open that. We see a 512 by 512 pixel image, 512 by 512, and it's an RGB. It's a red, green, blue color image. And if we move the cursor around in the image, we see up here the XY coordinates where we're at, and we see three values, 3 pixel values. The first is a red, the second is a green, and the third is a blue value at each point. So we're seeing a mixture of red, green, and blue wherever we look. We've got here 216 units of red, 175 units of green, and 165 units of blue. We'll make a duplicate of this as we usually do. We want to get into the habit of making duplicates. And we look at either one or the other, click on one or the other, and go into Image, Color, and Split Channels. That is, the color is made up from 3 channels. So if we split channels, we see the red, green, and the blue channel separately, and we can move within each and see how much green at a certain position, how much blue at a certain position, how much red at a certain position. But they're not colorized, red, green, and blue. What we can do is go down to Image, Color again, and merge those 3 channels back again. Those 3 red, green, and blue channels. Here they are. Create a composite image, which is this here, which is our red, green, and blue in a slightly different format than the original. We can also get to here by taking the original and making a duplicate of it, and then going down to Image, Color, Make Composite. That'll get us to here. So either we split it into red, green, and blue and then merge it back again, or we make a composite. But in either case, we end up here. And if we go to Image, Color, and split the channels of this composite image, we see the red and the green and the blue, but this time they're colorized. And we move inside, we see the red values, the green values, and the blue values. So we've got 3 planes, a red, green, and a blue, that sit on top of each other, and we're looking through all 3 of them, and we're getting a colored image. This colored image has got 8 bits of red, 8 bits of green, 8 bits of blue. On the red plane, a 0 value comes from black. There is no black here, but there are some dark pixels. And then a bright red, the reddest value, will give us up to 255. Similarly, in each of these other planes, 0 will be black, and the brightest green will get up toward 255. So we've got 3 planes, each of 8 bits. The final color image, when we combine the 3 planes, is a 24-bit image. 8 bits of red, 8 bits of green, 8 bits of blue. And with 24 bits, the number of actual colors that we can see in this is 2 to the power 24. Right? It's 2 to the power 8 in each of these. That runs from 0 to 255. But in this, it's 2 to the power 24, the total number of colors. 2 to the 10 is kilo. 2 to the 20 is mega. 2 to the 24 is 2 to the 4 times mega, or 16 mega. So we have over 16 million colors in this image here, and sometimes referred to as a millions of color image or a real color image. So we go back to the color. Let's take away the three separate planes. We've got this image. We'll duplicate it as usual, and we'll look in the image type, and we see its RGB color. And of course, as we move around within it, we see the red, the green, and the blue pixel values. But if we look in image type, there are different types. 8-bit is really 8-bit gray. That's what we have been used to up until now, 8-bit gray images, 8 bits per pixel, grayscale image. And I mentioned we're going to have 16 bits per pixel or 32 bits per pixel. These are all grayscale images. And we have this one, which is RGB color, which is actually a 24-bit color image. But there's another type of color, and it's called 8-bit color. And we'll change this here to 8-bit color. And it doesn't look much different from the original. There's a little bit of a problem here. We're getting those false contours, because in this 8-bit color image, we only have 256 colors to work with. We don't have enough colors to display this properly. Here we have 16 million plus colors to choose from. So we can see the image, very well. We can distinguish small changes, not so well here. If we look at this, this is this 8-bit color image, or sometimes called indexed color image. If we look at color on it and look down to display LUTs. LUT is lookup table. We'll have a look at that again. Lookup table, but let's display the lookup table. Sorry, not display lookup tables, but edit lookup table. And we see the actual lookup table that's relevant to this picture here. It has 256 colors only, and they're the colors that are needed to paint this picture. Not the 16 million colors, but just 256. 0, if we come across a bit, 0 gives us black, 1 gives us this color, 2 gives us this, 3 gives us this, all the way up to 15, 16 to 31, 32 onwards until we get to 255. So this lookup table or palette for an index color or an 8-bit color image looks like this here. We see the 256 colors. We can take this original RGB color image again, duplicate it once more to work with, go to image type and change it to an 8-bit gray. If we do that, we throw away all the colors and we have an 8-bit image, just like this is 8-bit, but this is 8-bit gray. There are only grays, whereas here there are 256 special colors. And if we look at this and look in image color, although it's a grayscale image, we look at color and we'll go to edit lookup table. We see the lookup table. It goes from black, 15, 16 to 31, etc., to white at 255. That's the lookup table for this image here, all grays. I want you to get used to looking in this help documentation. Will take us to this page here, and if we go to menu commands, we can scroll down here and see the menu commands: file, edit, image, etc. We go to image, we go to color, and this gives us details of what we were doing when we were splitting channels, merging the channels, making a composite, and so on. So I want you to refer often to these pages here in the documentation so that you know what's actually happening when you're clicking things within the drop-down menu. And that's it for color images. So RGB color, 24-bit color, 8-bit color or indexed color, and then we can take the color out and we have our 8-bit gray images.